So I did post the key to the exam. If you've got questions, take a look, come talk to me. I was very happy with what I saw. I would like you to go back and look at the questions for chapter 1 that we did for homework and say, okay, which of these were most helpful, least helpful in terms of getting you to understand the material, not just the exam. Well, which is more helpful in getting into material. So I'm going to rely on homework. I was looking at chapter 2, and I'm pretty sure it's going to take us longer than the time I've specified for chapter 2. So we may have to rearrange the schedule a little to allow for some more days to cover the rest of this material. We'll see where we are today and then Tuesday, and we'll do some rearranging as needed. When I left off last week, we're talking about present value of an annuity. We talked about this idea of a perpetuity. Let's suppose I want to give a scholarship. It's not a huge scholarship. I'm going to give $500 a semester to one student. Let's go to a year. Make it easy. We'll do it a year. $500 a year. Just one student, I need to come up with $500 a year. If I put enough money in the bank today, I should be able to do this forever. What's the interest rate that you think I could get right now on a couple thousand, 10,000, 100,000, somewhere in that range deposit? What do you think is the good interest rate for me to say, if I put this in the bank or in an investment, I'll make what? 5%, 3%, 2%? What do you think I'm going to get? Okay, so let's say I can get 3%. How much do I need to put in the bank today to, at the end of this year, the first year, have $500 to give away? Well, realistically, if I put in like $491, I'll earn 5% of that, 3% of that. I'll have $500, I give it away, but then I'm broke. I would like the $500 to be the interest every year. So I can always have $500 to give away. Okay, wait a second. We're thinking of the present value of money, right? So every time I go to bring back $500 the number of years, I'm going to have another V on there, right? So I'm going to get 500V plus 500V squared plus 500V cubed plus dot, 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 dot. But instead of ending, I want this to go on forever. That's an infinite series. I'm in Calc 2 again. Now, I do remember that there is a formula for an infinite series. I'm going to pull out a V so that this becomes the sum j goes from 1 to infinity, v to the j minus 1. And the reason I do that is because then it starts with v to the 0, which is 1, right? What's the sum of that infinite series? That's a geometric series. Anybody remember the formula for a geometric series? The internet is your friend. Google it. Okay, but this is just 1 times v to the, oh, so this is 500 v 1 over 1 minus v. Hey, wait a second. 500 v over 1 minus v. What was v again? V is
for 1 plus I.
so if I do a little rearranging, 1 plus IV equals 1. V plus IV equals 1. IV equals 1 minus V. I is 1 minus V over V. This is 1 over I. All I need to know is how much my payments are, and this factor right here tells me what the value of my annuity is. That does what we were doing with the AN angle I thing, right? But it does the AN angle I with n being infinity. Instead of an annuity, this is a perpetuity. What is this number for our case? What was our interest rate? 3%. So what's 500 divided by 0.03?
666.
If you put $16,666.67 in the bank, and it's going to earn 3%. A year from now, you'll have $500 in interest. You take that $500 out and give it away, you still have $16,666.67 in the bank, right? So next year it'll earn 500. You take that out, you give it, you can keep this cycle going forever. And that's what a perpetuity does instead of an annuity. An annuity is a finite length of time. A perpetuity just keeps going. A trust fund that issues you a check every month without fail. Same idea. And if I have that lump sum in the bank, it'll never stop. My parents who are retired have this idea with their retirement account. If every year the balance is still the same, they lived for free that year because they lived off the interest the bank gave them. There are 2 examples in the text, example 210 and 211, that use this idea fairly directly. I really think this is a brilliant idea. And that idea about thinking of n going off to infinity is really the key piece to me. By the way, I can use this to work backwards and think of the regular annuity as the difference between 2 infinite perpetuities. A regular annuity, let's say it was only going to last 10 years. Well, then you could say, all right, I'm going to take a perpetuity that starts today, then I'm going to subtract the perpetuity that starts in 10 years. And I'll get to 10 years in the middle. But that means I have to bring this one back. That means multiplying by v to the 10th. So I get 1 minus v to the 10th over I. That's exactly a 10I. Questions? In long-term financial planning, perpetuities play a very large role. Both personal and corporate perpetuity investment styles are important. We called all of the annuities we were doing, we called them ordinary annuities or annuity immediate. What made an annuity immediate? Promise, we had something that made it an ordinary annuity. What was that thing? The sequence of regularly spaced payments is just the definition of an annuity. But there was something about the way we set up the payments in terms of when they occur. They occur at regularly spaced intervals. That's an annuity. But they occur at what point in time? The same day as whatever deposit was going on was the day that we did what? We did the same, we made our deposit into the account, or we got the payment on the same time as the interest was calculated. And interest is calculated at the end of the period. So an ordinary annuity, an annuity immediate, is defined by the fact that the payment's made at the end of the month. It's defined by our valuation time. If we think about the time diagram, the loan is made here. And our first payment is made here. R for regular payment. And our last payment is made all the way at the end, right? And this is our future value. Notice that if we want to know the future value, we use that SNI. If we want to know the present value is ANI. But that present value is 1 month, 1 year, 1 period before the first payment, right? Now, if you think about this, if you're going to start putting money in the bank, will the bank let you open an account with $0 and keep their file on the computer for nothing until the end of the month when you give them the first amount of money? It's unlikely, right? You should walk into the bank and say, here's some money, make an account for me. You go to buy a car. What do they tell you at the first thing you have to do when you sit down to buy the car? You have to make the first payment. Sometimes you have to make it right then. Sometimes you get to wait a month, right? So there could be another valuation time. And that payment, instead of being made at the end of the period, could be made at the beginning of the period. If I walk into the bank with the money today, that's not here. That's here. So if I make my payments at the beginning of the period, whatever that beginning is, month, year, quarter, week, I would be making payment number 1 here. And I would be thinking of the interest continuing to be earned until here. Because I made the payment at the beginning of the month and I wouldn't take it out until the end of the month. So I'd earn more interest. I'd earn more interest here, wouldn't I? Because I'd have it a little longer, which means as I bring stuff back, I'd bring it back less far. We call this an annuity due. Because the first payment is due right now. I'm going to even go so far as to change the symbol. Instead of just using A and I, I'm going to put these 2 dots above the A. Instead of just using S and I, I'm going to put 2 dots above the S. The 2 dots are for the due. But let's think about this. What happens in my present value? For A and I, go back and look at the formula for A and I. You get the other color, so we have the right color with the right idea. A and I. We took our first payment back 1 month. We took our second payment back 2 months, our third payment back to our nth payment back. And when we did this payment, we got a formula. The formula for A and I is
SNI.
yes, but I wanted to adjust in terms of V here. That is correct. If I take the SNI and replace it with its term and multiply through, I get this. So what you said is correct, but go a little further back and we'll see the other version of the formula. SNI, wait a minute, I don't want to do SNI yet. Let's think about what happens with the blue up here. What happens if my first payment is due at the very beginning? Well, then ANI with the dots, what happens to my first payment? Do I bring it back at all? No, my first payment's made on the very first day. It doesn't have any change for its present value. But the second one only goes back 1 month, and the third one only goes back 2 months, and the last one goes back 1 fewer month. Because everything's ending here, we're going back 1 fewer spot. That's going to change the power, isn't it? That's going to give me 1 minus v to the n over 1 minus v by my geometric series formula. A r to the n over 1 minus r. That's changed from here. Wait a second. Wait a second. 1 minus v. One minus v. 1 minus v. There it is. 1 minus v is IV. That's I over 1 plus I. That's in the bottom. We gave that a name already. That's our discount rate. That's our discount. I knew discount would come back to us at some point. Now, I am personally bothered by that because I don't like thinking in discount. I like thinking in interest. So I tend to write this like this, 1 minus v to the n over I. Hey, that's the same 1 times 1 plus I. Which means that ANI is AN without the dots times 1 plus I. It's 1 month further forward in time. Multiply by 1 plus I to move the interest rate 1 month forward. With a similar calculation for S, we find the very same thing. Prove you that I'm not losing my mind. Here's our annuity formula sheet, right? The one you had on the exam. There's this whole section on annuities right here. Here's our ordinary annuities. There's our formula for A. There's our formula for S. Sn is an 1 plus I to the n. That's the formula you gave me, isn't it, Adam? But here it is just in terms of I. Same thing with an. Here's the present value. 1 plus I times the an. Here's the future value. Sn with the dots is 1 plus I Sn without the dots. Kind of hard to see the dots without blowing it up. There we go. There are the dots. This is the way I find easiest to remember the difference between future value or present value of due versus ordinary. It's due now. I'm going to change my valuation by a month. At the top of page 91, there is a picture with all of the dates and periods indicated. When we were doing present value, we were one period before. That's why we kept writing a 0 above the timeline here. When we do the due version of an annuity, it's on the first day. Our future value goes out another month. So we make the payment, or we make the deposit, and then you wait a month to take it out. And that's what that comes up with. So this to me makes a little more sense in the way we would actually do this. You're going to start saving money. Eventually you want to retire, or however long you're going to save money for. The problem I am doing says we're going to save $200 a month into an account earning 6% annually. In an account earning 6% compounded monthly. We started January 1st of 2009. In 2014, I lost my job. So I stopped saving and I missed payments 60 through 72. I got a new job and then kept going back. Assuming my last deposit was December 1st of 23, what is the value on New Year's Eve? This is an example out of the text. But I'm going to do this a different way from the textbook because as much as I like reading what the textbook did, I wasn't exactly thrilled with it. Let me tell you what the textbook did. The textbook said, hey, you started on January of 2009, you ended on January of 2023. How many payments did you make? If you'd made them all, how many would you have made? If I'd made them all, so ignore this part. If you made them all, 2009, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and 23 is 15 years worth of payments. So I would have made 180, not 168. Okay. They say, do all of the payments, then figure out the parts you missed here and subtract that off. I find that a little awkward because I'm confused as to, we missed these things, why would I want to do that? I'm going to do it in a different idea. What I'm going to do is I'm going to say, okay, on January 1 of 2009, I started making payments. I stopped on the 59th payment. I missed number 60. 60 would have been 5 years, right? So 60 would have been January 1st, 5 years later. That's a 14. So the last payment I made was 12/1 of 13. When did I start making payments again? I missed January, February, March, April, May, June, July, August, September, October, November, December. That's 60, 61, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I start making payments again January 1st of 15. Should be on the bottom. 1, 1, 15. Resume. And I stop 12/1 of 23, and I want the balance here. What I'm going to do is I'm going to do two annuities. I'm going to do this annuity, and then I'm going to do this annuity, and I'm going to add them together, rather than trying to subtract out the middle. I'm going to do the beginning and the end. How many payments did I make in here? 59. So here I have n equals 59. I have an interest rate per period of 0.06 over 12, which is 0.005. So on this day, right here, 1 month after the last payment is due, the value right here is 200 times S double dot 59.005. Because I made the payments at the beginning, not the end. With me so far?
How do you know to use like EM formulas and stuff like
Because I'm making multiple deposits. The regular compound interest formula is only one deposit. I keep putting more and more money in the bank. I got to add all the geometric sum up. That's why I know it's going to be the annuity formula. That's regular payments. But that's not the date I want to know stuff on. I want to know stuff here. This is December 31 of 23. That is 121 months after the deposit, right? There's my compound interest part, right? Because I stopped making those deposits and I just let them sit. So this is part one. Part two starts here, January 1st. Of 15. How many payments get made here? Careful. I'm not actually making a payment here. I'm calculating the date on the 31st, but my last payment is December 1st of 2023. That's also off. I started my payment January 1st. I ended December 1st. That's 12 in each year. It's actually 108.
We really go to 180 minus 73, that's, oh, you mean minus 72. Oh.
Really, I should do 180 minus 13, right? 60, 61, all the way to 72, right? But I already took away 59.
Yeah.
So I'm looking at the rest of them. 180 minus 59 minus 13 is 108. And this again is at J equals 0.005. So this annuity will be 200 S double dot 108.005. And that will put me at exactly the right date. All I have to do is add those together. Now comes all the math. $200, 1.005 to the 59th minus 1 over 0.005 times 1.005. Then times 1.005 to the 121st. Calculator time. I was doing something in the other class. 200 parentheses 1.005 raised to the 59th minus 1 divided by 0.005, that's this part, times 1.005, that's this, times 1.005 to the 121st. That's this part. I made these deposits for just shy of 5 years, and then I let them sit in the bank for another 13 years. Sorry, that's not right. For another 10 years. 25149.11. Now, this part, $200 a month, $1.005 to the 108 minus 1 over 0.005 times 1.005. How to write down the right number. Ooh, typo. Use multiply instead of divide. Divide. Much more appropriate. Times 1.005. So this is 28,690.72. Which gives me a total of $53,839. 58,000. I can write, I promise. $53,839.83. By changing the valuation date, I've changed substantially the amount of interest earned. If you have to make the first payment right now, Think about signing a lease for an apartment. What's due when you walk in? First, last, security deposit. First payment's due right now. That's a due, not an ordinary. Think about what's due when you walk in to buy the thing. If the first payment is due right now, or the first deposit has to be made right now, that's what's due, not what's ordinary. I know that's a weird sound because you think of ordinary as being the one most of the time what you do. Well, I walk in with the money. I really like using these valuation dates, either the day a period before, the day it's due, the last day of the deposit, or a month later. But those are not all I can do. If I set up that trust fund to pay out $500 scholarships with that 16,000 that we came up with at the beginning, what happens if instead of waiting a full year, I only wait 6 months, I say, how much is it now? I could do any of these other points in the middle and ask, hey, how much is this worth today? That's the current valuation. All I have to do is multiply by the appropriate 1 plus I to the whatever power to move stuff around, whether I'm moving it forward from here or backwards from here to get to the date I want in the middle. We talk about current values a lot when we think about money market accounts or stock portfolios or bond portfolios, because we think about all of these other instruments as having a valuation sometime in the future or sometime in the past and earning interest or discount along the way. Like, okay, wait a minute, what is it worth right now? Because that's what usually we think of somebody's value as financially. Jeff Bezos is worth X dollars. How'd you get that? Well, these stock options in the future are worth this much today, and these things that he has as investments from the past are worth this much today. Let's bring it all to one date. Questions? That's section 2.1. So let's make things a little more unusual and a little more accurate to the real world. One of the big problems we had is that the deposit was made on the same day as the interest was calculated, right? But I get paid on the last day of the month, and my bank account cycles every 10th of the month. I don't claim to understand this, but my bank pays interest on the 10th or the 12th or whatever the right 30-day period is. So I get my statement in the middle of the month with interest earned on this. In September, I earned interest on September 12th. But I got paid on the 31st, so that's really weird. What if we have differing schedules? My bank pays interest every month. So does my neighbor's bank, but she is a trust fund kid. She's unemployed and she gets money from her trust fund. The trust fund only pays out every quarter. So if she goes to put money in the bank, she only gets to put money in the bank every 3 months, but it still calculates interest every month. We could do this in reverse. We could have an account that calculated interest only on the quarters, but we put money in every month. I can use the same idea. I just have to convert the interest rate, because that's easy to do, to an equivalent interest rate to the deposit period. The thing I will have to watch out for the most is round off error. Because round off error will kick me in the teeth here. An example. I'm going to make a deposit every quarter. We'll make it a nice, easy number. Deposit 1,000 at the end of each quarter. From March 31st, 2008 through December 31st, 2023. Suppose my account pays 9% APR compounded monthly. How much do I have on December 31st? Of 2023. All right, wait a second. First question, I hope, is the easiest one. How many payments did I make? How many deposits? $64. All of 2008 through 2023 is 64 payments. It's 16 years. I know 23 minus 8 is 15, but I have to count 8 because I made payments during that month. Sorry, that year. I need to know two things. First, ordinary or due? Sorry, annuity immediate or annuity due. They use the other word in this textbook. So used to using ordinary, I apologize. Yeah, that's exactly what affects it. It's at the end of the month. So which is it? Exactly. Which means, since I'm calculating the future value, I want S, not S with the dots. I'm paying 1,000. S64 interest rate. I don't know what the interest rate is. I'm going to call it J. How do I figure out what this interest rate is? That would give me the rate per month, but my deposits are not made every month. They're made every 3 months. Unfortunately, no, because I'm still compounding my interest every 3 months, right? Every month. So I really need to take that 0.09, which I divide by 12, and I need to think about that compounded for 3 months. And then I subtract 1 to get J. That's my interest rate. I have to convert the monthly rate to a quarterly rate. When we were doing the problem on the exam between the two banks, I hope you like my banks, McNabb and Burns. The whole point was to convert to annual rate. But here, I don't want to go from monthly to annual. I want to go from monthly to quarterly. So that's why it's only to the third, because there are 3 months in a quarter. Now, I am going to be a pain in the ass. 0.09 divided by 12 is a nice round number. So it's 1.0075 to the third minus 1. I'm going to keep all the decimal places. Because I'm doing 4 payments per year, there are 3 months in each quarter. And this is a monthly rate that I now have to take 3 times in that quarter. Then my next payment, 3 months. Then my next payment, 3 months, right? You were the one who said, take it, divide it by 12, and then multiply by 3. Wouldn't that be divided by 4? Yeah. But I'd be multiplying by 3. I'm not multiplying by 3. I'm using the power of 3 because I'm doing compounding, not simple interest. So my pain in the neck part is that I need all of these decimal places. I promise there's a reason. 0.0226691719. So that is what goes here. And my future value, A, is 1,000. 1 plus J to the 64th minus 1 over J. I still have that number 1 plus J and J stored in my calculator. To make my life easy, I'm actually going to store that. So I don't have to keep typing all these decimals. Down here above the on button is STO store. If I hit that, it takes the number and stores it in whatever letter I want. I can use any letter in green above any of the keys by hitting the alpha button, alpha A. I will now store that as A. So now I can do this problem by writing 1,000 parentheses 1 plus A to the 64th minus 1 divided by A. If you really wanted to, you could call it J. There is a J button right here above the comma. But it doesn't matter. But now I have my value. I should end up with $141,076 and 10 cents. Let me show you something. What if we only kept 4 decimal places? 1,001.0226. Sorry, we'd round that to 7, right? Because it's 6. I'd round it up to the 64th minus 1 divided by 0.0227. We're off by $150 more. If I'm looking at a future value and I tell you you're going to get $141,240 and I show up later with $150 less than that, you're going to be pissed. And I think you have every right to be pissed. Now imagine this wasn't $1,000 a quarter. Imagine this was $10,000 a quarter, $100,000 a quarter. I'm a corporate account. I'm making a lot of different behaviors here. I really want all the decimal places. By the way, the same thing happens if I do present value, but we underestimate instead of overestimate. This is particularly important when you think about education savings plans. In Canada, it's the RESP. In Pennsylvania, it's the PA 529 account. That's how you figure these payments out. But PA 529s credit money, they credit interest every quarter. They only take deposits monthly. So this is exactly the problem I had to do to start a 529 for my son when he was born. Questions? If I make multiple payments a year, but I only compute interest once a year. So this was more interest than payments. What if I have more payments than interest? Again, I can convert one to the other. There is a notational change. I really don't like this notational change, but I will give it to you anyway. Consider the rate annually and payments made more than once a year. We're going to call this an mth, let's say m times per year. Call this mthly payable annuity. I think that's the weirdest notation I've ever heard. Mthly. Okay. And all I'll do is I'll convert my annual interest rate to the equivalent rate for whatever my payment frequency is. So let's think about what we were just doing. We were doing an interest rate at 9%, right? Wasn't that our interest rate there? So the previous problem, it was $1,000 every quarter. Bank paid 9% APR, but it was compounded monthly. What if I think about that as only being done once a year? Well, then my interest rate isn't 0.022 whatever, right? That's per month. My interest rate is 9%. Instead of 1,000 S64J, we can use 4,000 because that was what I deposited each year, right? And I did it 16 years at 9%, but I subdivided it into 4 parts. I think this is a dumb distinction. I think it's easier just to say, I'm going to convert my thing to quarterly rather than convert it to annual and convert the payment sequence. But in general, what I'm really doing here is I'm aligning everything to years instead of aligning to whatever the payment schedule was. I haven't seen this used as often, but there's an entire section in the textbook about it. I didn't want to just pass it up. And with the notation change, it is possible that that notation change comes out on the actuary exam, because it does come out in our alternate formula setup. Emsley annuity right here. Questions? We had all of this set up as discrete payments. Everything is distinct, discrete. We did continuous compounding, right? Or continuous compounding used our force of interest idea. So instead of making distinct payments, we made a continuous payment. I can do the same idea here. I can think about a continuous annuity. But a continuous annuity would be like letting M go off to infinity. So instead of making a payment 4 times a year, I make my payment 170,000 times a year. I just make it all. I let M go to infinity and I figure out what's going on. Well, it turns out that then we get an integral. I'm going to use a bar instead of the dots, right? The dots were for due. The bar is a continuous line. It's continuous. That's the integral from 0 to n of 1 plus I to the n minus t dt. Which gives us, I know how to do this integral. That's an exponential equation with the chain rule. So I get a -1 up there to use the u substitution, minus, and then the integral of a to the t is a to the t divided by the logarithm of a. And that then has to be evaluated from 0 to n. Wait a second. What happens when you put n in here for t? So something with 0 is? Then you put in 0, what do you get? For t. Minus a negative is plus 1 plus I to the n. Wait a second. 1 plus I to the n minus 1 over ln 1 plus I. When we did S, it was over I. When we did S with the dots, it was over the discount rate. Now it's over the logarithm. Where have I seen this logarithm before? This number right here. I've seen that number before. We gave it a name. Back when we did continuous compounding. So that's chapter 1, section 6.
Constant.
It is a constant, but we gave this particular constant a name. It's the force of interest for our continuous compounding. We called it delta. So I get 1 plus I to the n minus 1 over delta. If I didn't have a delta down there, but I had an I, that would be the regular Sn. So there's a way to write the continuous version in terms of the original. Okay, I would like you to note the derivation of this formula is on page 97. There is a typo in the book on page 97. I'm about to put that page on the camera. Right here. That minus 1 should not be part of the subscript. It should be below the subscript. It should be e to the n delta minus 1, not e to the quantity n delta minus 1. But that gives me the same result, rearranging our formula. I will rarely, if ever, actually have a bank think of an annuity behavior as continuous, but we can use this in approximation for something that happens daily, and it's pretty damn close when I do a daily approximation. Example 14 on page 97 does exactly that. I'm not going to run through the example, but it's the same calculation. By the way, the difference between the continuous version and the actual daily composition is about $2 or about 1/100%. Again, if I'm dealing with accounts whose numbers are in the hundreds or thousands or something, 0.01% might make a difference, but not to most everyday calculations. If it works for future value, it also works for present value. The same way. This, by the way, allows me to do the change in valuation date a lot easier because I'm changing an integral. And to change the day of an integral, I can go from A to C and C to B. To do A to B, that's one of the pieces of the fundamental theorem of calculus. It makes my life a lot easier to work with. I will say that a lot of this integration is literally used as approximations for dailies or as connection to just the theory of annuities. Questions? One of the most difficult pieces of this is actually solving for time. Whether I'm doing it for ordinary annuities, annuity due, or continuous annuity, solving for time is an awkward piece because it's in the exponent in two different places. I mean, solving for n is a pain in the neck. I'm not going to do it by hand. I'll do a lot of this on the calculator. I'll set up the equation, I'll plug it in, and I'll say, what's the value that I get out? I can do it sometimes. Let's think about this. Let's think about our future value ordinary, our accumulated value. Maturity, or A, equals a regular payment times SNI. I want N. Well, this is the same as 1 plus I to the N minus 1 over I. If I want N, how do I get N? I got to divide by J. I got to multiply by I. I got to add 1. Now what? How do I get that N? I can use the logarithm. ln 1 plus mi over j equals n ln 1 plus I divide, and I get ln of this ugly looking thing, mi over j, over, hey, wait a minute, ln 1 plus I, again, that's delta on the bottom, my force of interest. So if I am doing a normal ordinary annuity, and I know the future value, and I know the regular payment, and I know the interest rate, you can tell me how long it lasts. And there's an equivalent set up for the present value, right? I think it's easier to do these on technology. We'll set one up and do one next class. I am absolutely sure I'm going to need at least one extra day to do to finish all of chapter 2. So we're going to move some things on the calendar. I will work that out this weekend and send you guys a new calendar. It's going to change the date of the next exam and some of the homework dates. All right? Have a wonderful weekend. I will see you all on Tuesday.